All right, so I'm going to go through this problem pretty quickly. You might want to stop and recheck kind of what I'm saying along the way, rewind a little bit, stuff like that, because I'm going to go pretty quickly. All right, so the first step here is going to be to isolate this radical right here. And the way we're going to do that is the inverse of subtracting 1, which is adding 1. So we have the square root of x plus 7 is equal to x plus 1. Now, what that does is that when we go to undo or get rid of this square root by squaring, well, when we square the other side, we're now squaring a binomial. And when we square a binomial, we end up really having the quantity x plus 1 times the quantity x plus 1. And again, on the left-hand side, the square root and the square undo each other, so we're just left with x plus 7. The reason why this is important is because we're going to FOIL on the right-hand side. So we're on the left-hand side, we're gonna have x plus 7, and we're gonna FOIL firsts, outers, inners, lasts. Firsts, x times x is x squared. Outers, x times 1 is 1x, or just x. Inners is going to be 1 times x, or just x. And lasts is going to be 1 times 1, which is 1. Now I'm going to combine my terms there on the right-hand side, and I'll get x plus 7 is equal to x squared plus 2x plus 1. Now I have a quadratic because I have x to the power of 2, so I'm going to need to set one side, and I'm going to choose this left-hand side. I'm going to make it equal to 0. So I'm going to have to get rid of everything on that side. And so the first thing I'm going to do is I'm going to subtract x from both sides. So I'll get 7 is equal to x squared plus x plus 1. Now I'm going to subtract 7 from both sides, and I'll get 0, which is what I want, is equal to x squared plus x minus 6. Now we're in a situation where we have a quadratic, x squared makes it a quadratic, equal to 0. And that's how we can start to work with quadratics, is when they equal 0. But the next thing we're going to do, there are lots of ways. We're going to really factor is what we're going to do. And there are different ways to factor. And I'm going to just choose one that I often use. And I'm going to rewrite this up here. And it's called the diamond and rectangle, generic rectangle, box and diamond. There are lots of different names for it. Doesn't really matter. I kind of make a square here, and I make an X, and the X is where the diamond idea comes from, but I don't usually draw that in, so lots of people call it the X box when I do it this way. And what we do is we take the x squared term. Now if there's a coefficient in front of it, it goes with it. And I put it in the lower left-hand corner. Some people put it in the upper left-hand corner. It doesn't really make any difference. The constant, just the number, goes in the corner opposite the x squared term. And now I multiply those together. Negative 6 times x squared, the result goes right there. It's negative 6x squared. The x term, which in this case is just plus 1x, goes in the bottom. And we're going to fill in the left and the right-hand sides. And whatever goes there, they have to multiply together to give me negative 6x squared and add together to give me positive x. Now, since the product of those two things is a negative, product is the result of multiplication, so we're multiplying them together and we get a negative. The only way for that to happen is if one of them is a positive and one of them's a negative. So we have positive something x and negative something x. So we have to put a number here and here so that positive something is and times negative something is equal to negative 6, and positive something plus negative something is equal to positive 1. And so it's going to be a positive 3x and a negative 2x. And if you aren't sure how that works out, you're going to have a look at that and see if you can pause and see what I'm saying there. These two then come over and go here and there, and it doesn't matter which spot they go into. You could switch them around, it doesn't make any difference. So now we have, this is really what we're looking at now. We're done with the diamond or the X there. Each of the parts in this square or this box are the areas of those parts. So x squared is the area of this little rectangle. So we need to figure out length times width is equal to x squared. Oh, x times x is equal to x squared. Now, since this is x, we just said it was, then that means this is x. But this little rectangle has area 3x. So we need something times x to equal 3x. Well, that's just going to be 3 times x is 3x. Similarly, since this is x, and we know the area is negative 2x, so we know that this has to be negative 2. It's also important to see that since this is negative 2, this is negative 2. Since this is 3, this is 3. So 3 times negative 2 is negative 6. Good, that works out. It's really important that it does. Now what we've done is we've taken this quadratic here, which is written in standard form, and we've used this box and diamond or this Xbox method to rewrite it in factored form. And factored form uses these as the binomials. So we have the quantity x plus 3. It's plus because this is a positive 3. Times the quantity x minus 2. It's x minus 2 because this is a negative 2. So now we have two binomials, this one and this one, that we are multiplying together. So this and this, they equal the same thing. They're equivalent, but they're written in different forms. Standard form, factored form. And now this is where we use something called the zero product property. The zero product property says when you multiply two things together and the result is 0, either the first thing has to be 0 or the second thing has to be 0. They could both be 0 as well, but not in this situation. So either the first thing has to be 0 or the second thing has to be 0. Now, if the first thing is 0 in this case, then we can subtract 3 from both sides and see that x must equal negative 3. If the second thing is 0, then we can add 2 to both sides, undoing that operation there, and get x equals 2. So either x equals negative 3 or x equals 2. So we have a solution, but we need to check our solution. And so we need to check both of those. So first, we're going to use our original equation, and we're going to plug in negative 3 for x. So let's see, we have the square root of x. X is negative 3 plus 7 minus 1 is equal to, and x is negative 3. So let's have a look at that. All right, negative 3 plus 7, that's 4. So we have square root 4 minus 1 equals negative 3. Square root 4 is 2 minus 1 equals negative 3. 2 minus 1 is 1 equals negative 3. And that is not true. So not true. And that tells me that this is not a solution. It is called an extraneous solution. An extraneous solution. Notice that the word extraneous has the word extra in it. Extra, in this case, not a good thing. It means that's not a real solution. When we plug -3 in for x in this equation, it doesn't work. It's not a solution. So we're going to try the other one. We're going to try the square root of 2 plus 7 minus 1 equals 2. All right. Well, the square root of 2 plus 7 is the square root of 9 minus 1 equals 2. Well, the square root of 9 is 3 minus 1 equals 2. 3 minus 1 is 2 equals 2. That is a fact. That's true. And so this x equals 2 is the only solution for this equation. There was one extraneous solution and one real solution. And that is how we solve problems of that nature. I hope this is helpful. You maybe needed to stop and check your work along the way, and that's great. All right, thanks everybody.